Hello friends, in this video we are going to discuss the fourth numerical related to single phase inverters. So let us read the example. A single phase voltage source inverter feeding a purely inductive load. Okay, so load is purely inductive, right? As shown in the figure, right? So it is a full bridge inverter actually, right? Next, the inverter is operated at a 50 Hz in 180 degree square wave mode. Okay, so output voltage is a square wave mode, right? 180 degree square wave means what? It is the same as that of a normal square wave. Assume that the load current does not have any DC component. Okay, so load current is not having any DC component. Okay, means it is a changing only. The peak value of the inductor current I0 will be, okay, so our task is to find the I0 peak. Okay, and they have given the four options, right? So I0 peak we need to find peak value of the load current I0. Okay, so that is I0 peak, right? Now here we need to understand the load is purely inductive. Okay, so first thing is, can we draw the V0 waveform for single phase full bridge inverter? Yes, we can draw the time t 0. Yes, it is a t and here it is a 2t. Okay, so 0 to t it is a positive, t to 2t it is a negative. Okay, output voltage. Right? And what is the magnitude of that output voltage? It is the same as that of the EDC. It is a 200 volt. Okay. Next, what is the I0? I0 waveform. Yes, it is a for continuous conduction. It is starting from negative. Right? We have already discussed it. For continuous conduction, it is starting from negative. Okay. 0 t 2t. Okay. So I0 waveform will be like this. It is starting from negative. Right? And it is passing. Next. So if you check, yes, like this. Okay, so if you check, yes, the load is inductive, so definitely current flowing through the load should lag the voltage across the load by angle 90 degree. Okay, so this is t, here it is 2t we are having. Okay, so this 2t indicates one complete cycle, that is a 360 degree. So t indicates 180 degree. Okay, so can we say that this instant is nothing but, this is very important, right? Can we say that this instant is nothing but 90 degree? Okay, so this is time is t by 2. Okay, because t is 180 degree, right? So in order to get the 90 degree, it should be passing through the at the middle of the t, right? Middle of the t, right? Why? Because inductor current lags the voltage across the inductor by angle 90 degree. Is this clear? Okay, so here it should be t by 2, here it is t, and here it should be 3t by 2, 3t by 2. Are you getting the point? This is very important. This is very important, right? Next, what is this? It indicates the I0 peak. I0 peak, right? This is the I0 peak we are having. Okay, next, so if you check from 0 to, sorry, t by 2 to t, from t by 2 to t, yes, inductor stores the energy, and switches S1 and S2 will be in the on state. Okay, so switches S1 S2 will be in the on state, right? Next, so here if you check during t by 2 to t, during t by 2 to t, okay, switches S1 S2 are in the on state, right? So when S1 S2 are in the on state, the circuit will be like this. Okay, so current flows from supply 200 volt S1 load S2 and again back to the 200 volt. So this is the S1 here we are having, this is the S2, this is the S3, and this one is the S4 here, right? Next, it is given that the frequency is 50 hertz, right? So frequency 50 hertz means what? This 2t time, okay, indicates. So we can write as f is equal to 50 hertz. Yes, the time to complete one cycle, right? Time to complete one cycle means it is a 2t. Okay, is equal to what? 1 by frequency, it is equal to 1 by 50, right? So it is equal to 0.01. Okay, so if 2t is equal to 0.02, okay, if 2t is equal to 0.02, okay, so what is t? Therefore t is equal to 0.01. Okay, so t is 0.01, this t is 0.01. So from t by 2 to t, what this indicates? It is a t minus t by 2. Okay, so therefore it is a 0.005, right? So therefore T by 2 is equal to 0.005. Are you getting the point? Okay, so it is 0.005. Okay, so this is very important. Okay, because this instant, this time is only T by 2, right? So this time, okay, so this time is only T by 2, right? This time is only T by 2. Are you getting the point? Okay, next, now here from T is equal to, from T is equal to T by 2 to T. As we know, switches S1 S2 will be in the on state. So can we apply KVL to loop? Yes, KVL to loop we can apply. Yes, it is a plus 200, right? Apply KVL, you will be getting an answer, right? Minus 0.1 into di 0 by dt is equal to 0, right? So it is a plus 200 minus 0.1 di 0 by dt is equal to 0. Okay, so from this we can write di 0 by dt is equal to what? 2000. Okay, so di 0 by dt is 2000. Okay, so therefore can we write what is the di 0? Di 0 is nothing but the change in the current, okay, during T by 2 to T. Okay, so what is the change in the current during T by 2 to T? Yes, from T by 2 to T, the current is changing from 0 ampere to the I0 peak. Okay, so what is the change in the current? It is I0 peak. What is the change in time? It is a T minus T by 2. So it is a T by 2 only. Okay, so we can write it as, yes, this can be written as I0 peak minus 0 divided by T minus T by 2 is equal to 2000. Okay, so therefore this can be written as I0 peak is equal to 2000 into T by 2. What is T by 2? T by 2 is 0.005. So it is a 2000 into 0.005. Okay, so is equal to, if you check, yes, it is 2000 into 0.005. So it is a 10 ampere, right? So it is a 10 ampere. So I0 peak is 10 ampere. I0 peak is equal to 10 ampere. Very, very important expression, right? Numerical. Okay. The thing here we need to understand, as the load is inductive, right? As the load is inductive, therefore, yes, the current should pass, or current should lag the voltage by angle 90 degree. And on time axis where the 90 degree, yes, indicates, it is like a T by 2 only, because 1 T complete cycle is nothing but the 180 degree, right? It indicates the 180 degree of alternating cycle. Okay, so this from here to here, it is a 90 degree only. Okay, so this is a 90 degree. Okay, so T by 2 is nothing but 90 degree, right? So that's why current here, voltage is positive after t is equal to 0, current is positive after t by 2, that is after 90 degree. Okay, so that's why current is lagging to voltage by angle 90 degree. Okay, so the answer is 10 ampere, right? Correct answer is 10 ampere. Is this clear? Okay, so this is about the numerical number 4 related to single phase inverters. The next video we are going to discuss the fifth numerical. Thank you.